It's kind of like simple interest when you look closer, but when you zoom out, you would notice that it's behaving like an exponential function. Let's take an example and see what it means. And it goes like this. There is a principal of 10 rupees that you have borrowed with an interest of 100% per annum. Then calculate the compound interest for 6 years compounded annually. With the first line, we can deduce that the interest will be 10 rupees for 1 year because 100% interest rate on 10 rupees equals 10 rupees, and this will be our first step, just like we had in simple interest example. Now, predicting the interest under simple interest or compound interest do follow their own ways. In simple interest, we had help coming from linear functions, and we can see that in simple interest by the formula simple interest equals rate times principal into time, being analogous to y equal to mx. And in compound interest, we still get help from linear functions, but their rate increases with each compounding period while trying to mimic an exponential function. And you might ask, what is this compounding period and how much it changes the rate? Well, I think it's best to use an illustration to explain it. So consider you borrowed some amount X and you agreed to pay an interest of 100% per annum by compound interest. Okay, what this means is, according to compounding period, and let's pick compounding period to be 1 year. So what it means is, according to this 1 year, you will be paying each year the interest that you have calculated on the total amount of the previous year. So for this illustration, the interest for first year will be 100% on the principal, and for second year it will be 100% on the total amount of the first year, and similarly for third year it will be on the total amount of the second year, and so on. And if compounding period changes to 1 month, then you do all of this for each month. Now, going back to our example, we see it's compounded annually, so we do this each year. And after connecting all of these points together by using straight lines or linear functions, you can see how much the rate increases each time. And note that it increases not because the interest rate is increasing, but the number on which we are taking interest on is increasing. Now, to summarize all of this into an equation, we use A total amount equals P principal times 1 plus R for the first compounding period, times 1 plus R for the second compounding period, times 1 plus R for the third compounding period, and so on. And if interest rate doesn't change, then you can club them together. Also, convert the interest rate into the period that you are compounding if needed. Like, say, if the interest rate is 100% per annum but the compounding period is 6 months, then half is the rate that we will use. Now let's see how much is the compound interest for 6 years in our example. So as the principal is 10, rate is 1 by 1 and time is 6, then the total amount at the 6th year will come out to be that much. And by subtracting the principal from it, we are left with our much awaited answer, that. Now let's move to section 2, problem 1. Find the compound interest on rupees 16,000 at 20% per annum for 9 months, compounded quarterly. So the interest rate is 20% per annum, principal is 16,000, and the compounding period is 1/4 an year. We got everything we need. We simply substitute them into the relation and find out the total amount, and after that, the compound interest. Problem 2. The difference between the compound interest and simple interest on a certain sum at 10% per annum for 2 years is rupees 631. Find the sum. Step 1. Laying out the picture. So there is an interest rate of 10% per annum, which under simple interest for 2 years amounts to something, and under compound interest with the same interest rate and duration, it amounts to another thing, and the difference between them is given as 631 rupees. Step 2. Find the relation and solve. So let's consider the required sum is X, which satisfies the relation compound interest minus simple interest equals 631, and we know how to express compound interest and simple interest. Then by doing so and solving the above equation, we get the X, the answer. So go on, give it a try. And if you're new to this series, please look in the description. There will be a playlist containing all the videos in this series for you to follow along.